key in is turn. So think physically, don't think answers, right? I mean, if you just study answers, what's touching it? What's not touching it? We're just doing gravity for now. It's the motion, and you'll be good. Okay with that? So we're going to do some measurements tomorrow. So, and tomorrow I might, we'll see, I have to look at the timing, but what I really want to do is sit down with each of you and just chat with you, and it's fine, you know, see how you're doing, what's going on, etc., because I think it's important. You can do this stuff, believe me. People across the nation fail this course and repeat it, and then do well if they change their approach or, you know, their lifetime, etc. So I encourage you to do that. But let me just show you this. Everybody cool with this, sir, Bob? That's the answer. Always go there. Trust this. So slow down a little bit. Use the methods. You know, everybody's got some sort of method. I think my 5 steps really get at it pretty succinctly and point you in that direction. It's a little funny when we start going outward because it sure feels like something's pulling me out. Is something pulling me out? You got to blame it on something, right? What I feel is my wanting to go straight. Something's got to pull in. It pulls me in, I pull it out. But I don't care about it, right? I don't care about anything with me. So just focus on that. But it gets confusing, but it's cool when you get it. Okay. Good. So now, maybe we'll get into this other thing about free flight here and talk about coordinates and use that for tomorrow a little bit. So let me make sure I get that. Okay, that's Newton's laws applied to problems, and here we go. So I want to look at number 4 from the exam, and I don't want anybody to write. And trust me, all I care about is you guys doing well. But don't write, because there's a tendency, and I totally remember, like, oh, let me just hold on to that, I can't remember. But let's try to think it through and get it, and then redo it. So I really walked you through. This is the basketball one. So I'm going to draw this picture, and I'm going to try to sell you, because I want you to do well, on this notation, kinematics. Because even if you're clear, you can really mess up the T's and the X's with standard notation. So here's the picture. Let's watch. Right there. Okay. In a dream, you find yourself playing NBA basketball. LeBron James shoots the basketball at an angle of 62 degrees out from the horizontal, and at a speed of 7.44 meters per second. He releases the ball 7.4 feet above the ground. You are guarding him. You're 9.2 feet away. I'm going to shorten it, and you throw a shoe up, and you release it 6 feet above the ground. So watch what I do when I draw this picture, because when I've got this picture, it's pretty much done. If I don't have this picture, I'm lost, and it takes me a ton of time. Here's the picture. LeBron James, Cleveland Cavaliers, red. Okay, important. Here's the ground. Here we go. LeBron James, however tall, doesn't matter. He's going to release the ball, so he's here or whatever. He's releasing the ball here. And he's releasing it 62, so make it more than that. Don't write. Just imprint this, right? So I'm going to call, this is the ball, and I even gave that to you to call that the ball. So I call it V ball 1. When I do these states, I'm taking a snapshot, draw a snapshot. The process is a movie, but I take a snapshot there. So what I've got is theta 1, and if you want, theta of the ball 1, is 62 degrees, right? I've got V of the ball at 1 is 7.44 meters per second. I'm just writing it down. I'm going to take my time here. This takes me a little bit of time. Let's see, he releases it 7.4 meters, which is equal to, I converted before, to, what was it? feet converting to 2.3 meters. Okay, fine, 2 sig figs. And that's how tall that is. Now you're over here playing for the Warriors, so you're blue. And you're here, and you're going to release your shoe. Now I like rectangles and circles so they don't get messed up. And the police and the speeder, a lot of people really mess it up. And all you need is, here's your V of the shoe at state 1, right? At that moment of time, this is all state 1. Don't call it 1 and 2. So there's a lot of mistakes, and I can't sit with all of you for as long as we need, so I wanted to do this. I do know also that this is 9.2 feet away, which is equal to 2.8 meters. So then I got that. And then state 2 looks like this. So I know the ball is going to go like this. There's a line of projection, but of course the ball is going to go like this. And I don't know whether it's going up or going down or whatever. I can't really tell. Let's say it's here. Or it still could be going up, or it could be the top of the path. I don't know that. But I do know that state 2 is when it hits, right? So that's at state 2. Now, I'm going to look just before it hits, so that's V of the shoe 2. And this is V of the ball at state 2. Time, displacement, velocity, and acceleration. All right, cool. So I have that. Oh, and I've got that how high this is, 6.0 feet, which is equal to 1.8 meters. Great. So what is this? What's that? What would I say symbolically? How would I put that in as variables that I won't lose track of the meaning?
Delta y from 1 to 2.
Delta y of what?
The shoe.
The shoe, 1 to 2. Trust me, I mean, I see it. Every time I grade, I see, oh, they messed up because they lost track. Of course, because you can't keep all in your head. There it is, right? That's delta y. Where's delta y of the ball 1 to 2? And I'll assume they're on, I'm not worrying about the size of it, right? So there's delta y of the ball, 1 to 2, right? Pretty cool. What didn't I put on here that I should have done right away? Coordinates, right? So plus x for both of them, x equals 0, that's fine. And plus y, ay for both of them is negative g. Good. It's quick. How can you relate these two?
Sure.
1.88, 2.3. That's the 8th equation. If you got that far. There's one equation that says delta y of the shoe 1 to 2 is equal to delta y of the ball 1 to 2 plus 0.5 meters. My picture tells me that. I can't read and get all that out of my head. And then what do? Then I go like this. I can go ball. I can go delta x 1 to 2 is equal to, I should be able to do that. V ball 1 cosine theta 1 delta t 1 to 2, right? That's the x component. Cool, delta y 1 to 2, oops, but look, I didn't do it. I didn't put ball, and I'm going to mess that up if I don't. It's tedious, but it saves me a ton of time. V ball 1 sine theta 1 delta t 1 to 2 minus 1/2 g delta t 1 to 2 squared. V ball 2 y component is equal to V ball 1 y component, which is V ball 1 sine theta 1, minus g delta t 1 to 2. V ball 2 y squared equals V ball 1 sine theta 1 squared, minus 2g delta y ball 1 to 2. Shoe's easy. No x component, so delta y of the shoe. And if you don't do B and S, you're going to mess that up. So if the shoe 1 to 2, the delta y, I don't care about its position. That's so slow. I want delta y ball is equal to v of the shoe at 1. Delta t, make sure you're checking your units, minus 1/2 g delta t 1 to 2 squared. V of the shoe at state 2 is equal to v of the shoe at state 1, it's all 1d, minus g delta t 1 to 2. And v shoe state 2 equals v shoe 1 state 2 minus 2g delta y. Shoe 1 to 2, it's a pain, but it'll always work. It'll always work. And then if I check that off, I'll go, oh, these are actually only 2 independent equations. So I can only solve 2 unknowns. But that's pretty nice often. I got another equation here. I've got 2 independent equations here, and one equation here. And the rest is simple algebra. That's where the work is done. The simple algebras. So, you know, do what you like, but I see T's. No. Don't do it. You know why? This is the solution manual. It's killer. I will tell you, it's killer. Until you sit and think it out and struggle with it, you really won't get it. I know the tendency, I totally know. But if you just do that and say which object and what states, when you do that, you'll go, I knew all that. But when you write it out like that, it's easy. Honestly, it's just whatever algebra. And it's not always easy. But in that case, it falls right out. So I hope you know you can do this. But I hope I sell you on the fact that what's going to get you past all those silly little mistakes. You know, I saw people getting C's